This is part 3 of the capital allocation line videos. We worked on these calculations on previous videos, part 1 and part 2. We will now work with the capital allocation line tables and the efficient frontier for comparison. For the capital allocation line, the idea is to combine the optimal portfolio with a risk-free asset in order to achieve different levels of returns while maintaining the maximum Sharpe ratio. It's pretty straightforward. We have a risk-free asset at 3%, and then we have the optimal portfolio we're going to be using. And all we have to do is assign weights and then calculate the items over here. So let's say we start from a point where all the funds, all the capital is dedicated to the risk-free asset 100%. That means that we will have 0% on the portfolio. So if we calculate the returns on that, we get the risk-free asset times the 3% it returns plus the portfolio weight times the return of that portfolio. And what we're going to do, we're going to go ahead and lock in the return of the risk-free asset and lock in with the dollar signs the return on the portfolio, so we can then drag it later when we want to. Okay, so let's do the standard deviation of this portfolio. Well, we are going to use this formula here to get the standard deviation of a portfolio like that. Now, this is a special case of standard deviation because we're combining a portfolio that has a standard deviation with a risk-free asset, which by definition does not have a standard deviation. So we're going to call this the complete portfolio. That's why the C there is going to equal the weight of the portfolio times the standard deviation of the portfolio. So what we do is we multiply the weight of the portfolio times the standard deviation of the portfolio that we're using. We're going to go ahead and lock that one in place with dollar signs as well. The Sharpe ratio here does not apply. We could submit the formula. However, because it's only on the risk-free asset, there is no standard deviation. So it'll be like dividing by 0. So it would not apply here. However, let's go ahead and drag this one down where we're going to have 50-50, for example. These weights are just selected at random. You can put anything in between if you want to. This just you can see the relationship as we go. And since we did the formula here, I can just drag that down as well. Now that portfolio, 50% of the risk-free asset and 50% of the portfolio, that complete portfolio, it's 4.85% returns. And let's see what the standard deviation will look like. 3.02 standard deviation. Now let's go ahead and apply the Sharpe ratio formula there. So that would be the return of the portfolio minus the risk-free rate. Allow me 1 second. Let me fix that. The return of the portfolio minus the risk-free rate. I'm going to lock that in so we can use it in the next one. Divided by the standard deviation of the portfolio. As you can see, the Sharpe ratio held at the maximum Sharpe ratio available to us with those portfolios. So if we go ahead and just work the rest of them as such, notice that even though our returns are going up and our standard deviation is going up, it follows the same relationship between risk and return. This case here, where you see the negative 200, that is a situation where we are borrowing money at the risk-free rate and then using that borrowed money to invest more in the portfolio, but you still have the efficiency of having the maximum Sharpe ratio available. So now what we're going to do is we're going to go ahead and do an efficient frontier table so we can compare this strategy with a risk-free asset involved or a strategy where we don't have the risk-free asset involved. So same thing. 1 minus the stock fund available. That means we put 100% on the bond fund over here, and 0 on the stock fund. Let's go ahead and take that all the way down. Let's try that again. Something got shifted, but there it is. Okay. So notice 0, 100, 595, 1090, etc. So let's calculate the expected return of these combinations, these portfolios. So what we do is we take the weight of the stock fund times the return of the stock fund over here, 10%. We're going to lock that one in. Plus, let me see if we can capture, there it is, the weight of the bond fund times the return of the bond fund. We're going to lock that in. And we get 5% expected return. Makes sense. 100% of our capital is there, so you only get that. Since we locked those in, we go ahead and drag everything down. As we combine the stock fund and the bond fund, notice that our expected returns are going up until we reach 100% of the stock fund and 0 in the bond fund with 10%. Now let's do the standard deviation. We're going to follow the same formula here, which on the previous videos we used for this, this and this. So if we go ahead and do the square root function, and we start with the weight of the stock fund squared times the variance of the stock fund. I'm going to lock that one in. Plus the weight of the bond fund squared times the variance of the bond fund. I'm going to lock that one in. Plus 2 times the weight of the stock fund times the weight of the bond fund. I'm going to go ahead and just punch it in. Sure everything is okay. Times the correlation between them two. And then that times the standard deviation of the stock fund. I'm locking these in. Times the standard deviation of the bond fund. And I'm locking it in. Okay. And that is our standard deviation for this portfolio. Now it makes sense as 8.27% because 100% is the bond fund. However, as we shift capital between funds, our standard deviation starts taking advantage of diversification. Now notice how it's dropping standard deviation, but after a certain point here starts going back up. We're going to address that in a moment. Okay. Now the Sharpe ratio, standard procedure. We're going to go ahead and take the expected return that we calculated minus the risk-free rate. I'm going to lock that one in, and we're going to divide it by the the standard deviation. And if we drag that down, it fills it in, and there we go. Same thing. Notice how the Sharpe ratio is going up, but then a certain point starts going back down. All right. And we'll talk about that in a second. Now, we do know that we have a minimum variance portfolio, and this is a spot somewhere in this table. That's a spot somewhere in that table. So what we're going to do is we're going to go ahead and place these weights somewhere. We're going to insert it in the table so we can keep track of the minimum variance portfolio. So notice there, we have the 25.34%. That means that that belongs somewhere between these two spots. So I'm going to go ahead and insert so we can add those. So the stock fund on the minimum balance portfolio is 25. Excel is smart and it auto-populated everything because it just followed the same formula as above and below. So what happened? Now that we have the weights of the minimum balance portfolio located where it belongs in between those two, we can see that the number is very similar to this one because they're so close together. Let's give it another decimal so we can appreciate when it starts changing. Notice that it went up a little bit. I'm sorry, it went down a little bit, but then it goes back up. So that's as low as you're ever going to achieve with these settings. So let's call that MVP. Now let's go ahead and place this optimal portfolio somewhere in here. So now we know that that's our lowest standard deviation we can achieve. Let's see the highest Sharpe ratio we can. So this was 34.04. So that belongs somewhere between these two. So let's go ahead and insert. Give it a couple of decimal spots so we can appreciate the difference. And what we're doing is we're dropping the formulas. And as you can tell, the expected return is the same as there. Standard deviation is as calculated as there. And more importantly, the Sharpe ratio is there. So what happens, we're seeing is the Sharpe ratio is going up, but then it starts going back down after that. So this is the highest number we can achieve here. So we're going to put there max Sharpe ratio. This is why this here is important, because it'll belong somewhere in the here too, because everybody will have that as well over there. Okay, now, but let's compare this minimum variance portfolio with the capital allocation line set when you include the risk-free. All right. So we're going to work a little bit in reverse here, because we're trying to find where these returns belong in here. Okay. Now we know that the expected return, 6.27%, will be somewhere between these two. Right. So let's go ahead and insert. Let's go ahead and grab it from here. Insert, shift cells down. That way everything stayed aligned. So we're going to start working in reverse a little bit, or somewhat in reverse. We know that one, that's the return we're looking for. Where does it belong in here? But we know it's somewhere between here. We do know that our Sharpe ratio should be the same. Let me ignore these errors, because that's the rule on this situation. So if we have the returns and we have the Sharpe ratio, we can then find out the standard deviation that belongs to that. And what we do is we grab this formula and we turn it around. So if I want standard deviation, what I gotta do is I gotta take this and divide it by the Sharpe ratio. So I'm gonna take the expected return minus the risk-free asset divided by the Sharpe ratio. And that's the standard deviation we should have in order to achieve that Sharpe ratio and stay within the capital allocation line. So working in reverse again, we go to this formula now. Now we're looking for the portfolio weight, that Y. So I take the standard deviation of the complete portfolio and divided by the standard deviation of the portfolio, then I'll get the weight that belongs there. So we're going to take this divided by the standard deviation of the portfolio over here. It's telling us that we should have an 88.25% weight on that portfolio. And now we just do the difference. And it means we need about 11.75% on the risk-free asset. Why did we do this? What we're doing here is we compare to MVP. The point is that this return of 6.27% is the same as this return of 6.27%. However, the standard deviation here was 5.67%. Let's take those back. The standard deviation here was 5.67% for that return. Here we have the same return for a lower standard deviation. So I'm achieving the same return for a lower risk. So that's the advantage of combining it with a risk-free asset. I can achieve the same return for a lower risk. Now, to get a better visual of this, we're going to build a table, a chart. I'm giving me some space here. So we're going to go ahead and grab the returns. And we're going to grab the standard deviation. And we're going to go ahead and insert a chart. Go to all charts here. We want to use the XY scatter, and let's use the scatter with smooth lines. Now, I'm aware that this looks a little inverted, but allow me 1 second. We just have to play with Excel a little bit. The problem here is that Excel automatically puts the standard deviation on the Y and the returns on the X, but we want the returns on the X and the standard deviation on the Y. So what we're going to do is we're going to right click on the chart, select data, edit, and you see here series X values, series Y values. That's what we're going to change. So I'm going to delete the X values in there. And remember, I want the standard deviation on the X values. So I'm going to select those. And I'm going to do the same for the Y. I'm going to delete there. And we're going to put the returns on the Y. Then we're going to hit OK. We're going to hit OK again. And now we have the graph that we're looking for. Let's clean a few things. So what you have here is the capital allocation line is a straight line. That represents these here. This here is what they call the efficient frontier. And those are this longer table here. The idea is that the minimum variance portfolio, it's somewhere here. The optimal Sharpe ratio is going to be where this line touches this line here, this curve here. But as you can see, the capital allocation line, which is the one combined with the risk-free asset, gives you an opportunity set that you can get the same returns, but for lower standard deviation, or higher returns for the same standard deviation. And that is the advantage of the capital allocation line when you have a risk-free asset involved. You can actually do lower standard deviations or higher returns for the same standard deviation. And that's it for this portion of the video on capital allocation line. This is the last video of the series.